Hey everyone, so this is Rishendra. So today we will continue with fast API HTTP methods. So in fast API, you define HTTP methods by using route decorators on your application instance. So these decorators uh, map incoming HTTP requests to specify Python functions. So I told you yesterday about core HTTP methods. So Fast API supports all standard HTTP operations out of the box through corresponding methods on Fast API app instance or an API router. So there are five core HTTP methods. So the first one is get, which is used to read or retrieve data from the server. Second one is post, which is used to create new data and submit request payloads. The third one is put, which is used to completely replace or uh, update existing data. The fourth one is patch, which is used to partially update specific fields of an existing resource. And the fifth one is delete, which is used to remove data from the server. So these are the five HTTP. These are the five HTTP operations and HTTP methods. And I will explain about each HTTP method about how to use in a program with this example here. So I created this example to explain you about the HTTP programs, HTTP methods. So first, so first is the setup, and first part is like the setup and data validation. So before any data moves around, the API needs rules. So fast API uses a pydantic to enforce these rules. The next is app is equal to fast API. So this initializes the core application. So it is the engine that listens to incoming web requests. Next, class workout base model. So this is my strict data contract. So whenever a user tries to send data to the API to create or fully replace a workout, it must be a JSON object containing exactly a string, an integer, and string and two integers. So here the string is exercise and sets is one integer and reps is the other integer. So if they send a string for reps, then fast API will automatically reject it. Next is the class workout update. So of the base model. So So I created this specifically for partial updates by setting the types to int none is equal to none. So this is basically like I'm telling the API the user might send the sets to might send the reps or they might send nothing at all. So accept whatever they give us. Next is the mock database. So here workout DB is workout DB. So in a real application, I would have connected this to a database like MySQL or PostgreSQL. So for this example, I'm just using a standard Python dictionary stored in the server's memory. So the keys 1 and 2 act as the unique IDs for the workouts. Next are the endpoints, which are the HTTP methods. So this is where the API interacts with the outside world. So each block uses a decorator to tell fast API which URL and HTTP method um, should trigger the Python function beneath. So the first method is post. So the its purpose is adding a completely new workout to the dictionary. So it takes the ID from the URL and the JSON body. So first it checks if that ID already exists. So if it already exists, so if it does, then it throws a 400. So if it already exists, so it throws a 400 bad request error. And if it is new ID, so it converts the pydantic model into a standard dictionary using model dump and saves it to workout DB. Next is get. So get function is used for viewing the data without changing anything. So how it works is first I wrote these two. So the first is so the first one workouts just returns the entire dictionary, and the second one workouts workout ID. So looks for it also returns dictionary, but it looks for a specific ID. So if you ask for like ID 5 or ID 99 and it doesn't exist, so it throws an error. Next is put. So put it's like a complete replacement. So it's like overwriting an existing record entirely. So if you use put on ID 1, it expects a full payload. So it takes the old data sitting at ID 1 and completely crashes it with the new model dump. So if you leave out the exercise name in your request, Pydantic in will throw an error before the code even executes. So next one is patch. So patch is like updating partially. So if you want to like tweak one or two things without having to send the whole object, so you can use patch. So this is the most complex function. So I use workout update model here. So the magic happens at workout update dot model dump. So yeah, so the magic happens here. Workout update model dump. So this tells Pydantic to only give me a dictionary of the fields the user actually typed in. So I then loop uh, those specific fields and update them in the existing database record, leaving the rest untouched. And the last one is the delete, which is used to wiping a record. So it checks if the ID exists. So if the ID exists, then it uses the standard Python delete keyword to remove the key value pair from the workout BB dictionary entirely. So let me show you the execution of this. So here, so I showed you yesterday about how to execute. So you can say this, and you can see I saved it as main.py. So here, yeah, you have to type as uvcon main app reload. So I told you yesterday that uvcon is used for running the fast API. So Fast API, it's a program, and UVCon is used for running the Fast API programs. So, and this is the executed program. So here you can see it's a gym tracker API, and here the first one is get/root. So this prevents, I also wrote this one there. So this prevents the if you after writing get if you add a root endpoint, so this prevents the not found error when visiting the URL database. So now here you can put it as try it out and see, you can see that no, there are no parameters. So even if we execute, there's like no parameters, so it basically gives you like nothing. So it just says welcome to API or add docs to in the browser to test the endpoints. So next one is post. So this one is used for creating brand new resources. So and here you can if you click try it out, you can see workout ID. So you can put it as maybe one. And then if you click execute, you can see the details. So it says code 400 undocumented. So here, so now it is undocumented. So now here, if you say try it out and workout ID one and execute, so it executes. So here you can see exercise bench press sets for reps 8. Here also you can see workout ID already exists. So which means I kind of like tested this before. So it does say workout ID already exists. So now if you take this out and add maybe two and then execute. So yeah, I already tested like a lot of these. So it may show uh, that. So next you can see the sets, the reps and all. And here the put. So if you can click try it out and workout ID maybe two, and you can click execute, and you can see it shows like sets 0, reps 0. and also the strings and all, and the patch. So it's used to update specific fields. So you can see like one and sets, you can change it to like five, and reps, you can change it to maybe 10, and then you can click execute and see, and you can see that the sets and the reps change it from 4, 4 and 8 to 5, 10, and then delete. So you can just click try it out and just press 2, execute, and you can see the workout has been deleted successfully. So now if you like again click try it out, execute, and since there are no parameters, see I use get to retrieve data without modifying anything on the server. So if you just use execute, so workouts 1, sets 5, reps 10. That's all. So this is one. So this is the fast API HTTP requests. So now for the next one. So this one is async. So this one is called async programming in the fast API. So asynchronous programming in Fast API, it enables your API to handle thousands of concurrent requests on a single worker thread by leveraging Python's async or wait paradigm instead of keeping paradigm. So instead of keeping a thread idle while waiting for input and output operations, Fast API's event loop pauses the current task and moves on to fulfill other incoming requests. So, Fast API is slightly unique because it supports both the asynchronous and it supports both the synchronous and asynchronous endpoints natively, but handles them differently under the hood. So, asynchronous defined endpoints. So, Fast API runs these directly on the main asynchronous event loop. So, this provides maximum performance for non-blocking input and output tasks, and then normal defined endpoints. So fast API automatically offloads standard synchronous routines into a separate external thread pool. So they are then awaited. So your overall server remains responsive without blocking the main event loop. So now this is an example I wrote to explain the asynchronous program. So let me just mm, remove this so that, yeah, this is good. And let me just do this. Okay. Yeah. So here you can see I imported the library. So fast API creates a fast API and import async IO. So import async IO provides asynchronous functionality. So and here you can see this is used for creating fast API application. This means this creates a fast API server. And then here you can see at the rate app process async def defined process data. So this is an async endpoint. So this tells the fast API that this function can perform asynchronous operations. And you can see await async dot sleep of file. So instead of stopping the server entire server for 5 seconds, fast API can handle other requests. Now executing this is a bit different. So here, let's open the command prompt. And here you can see I saved it as async.py. So when I type it in command prompt, I will say um, uv space async app reload. So here you can see I changed it from main to async because here the file name is async. So then you run this and then here you can see the request, the location, and then type this, copy this, and then paste this here. See, you can see it's showing like this, but here you have to type it as slash process, and then you run it, and then after that, immediately you have to run this. So here, so you can see that if you, since I typed process, here you can see the message as processing completed after 5 seconds. So this means you can see that this, since I wrote it as process data, you can see the message as processing completed after 5 seconds. But since I wrote, um, since I executed this normally, it's showing fast sync programming, and which is this one. So this is like a normal synchronous program, and this one is a synchronous program. Uh, So the difference is when putting in the HTTP, all you need to do is uh, HTTP. All you need to do is add slash process. So it shows the difference in the asynchronous behavior between the two links. So yeah. So that's it for today. And there are like two more topics in the Fast API. And after that, we will start React. So let me just stop the sharing. So yeah, that's it for today. And yeah, thank you all for watching. And I'll see you tomorrow. So bye.